Okay, hello and welcome to today's PSU Friday Transportation Seminar. My name is Leming Wang, and I will be moderating today's seminar. Thank you. Our Friday Transportation Seminars have been a tradition since the year 2000. Those seminars are usually held live on Portland State's urban campus, located on the ancestral homelands of the Monoma, Kathlamet, Clackamas, Tonwater, and Walala bands of the Chinook, the Tualatin, Kalapuya, and many other indigenous nations of the Columbia River. It is important to acknowledge we are here because of the sacrifices forced on the indigenous ancestors of this place, remember those communities, and to honor their legacies, lives, and destinies. Today, we're pleased to have Ben Stabler and Theresa Conley presenting Building Oregon Statewide Multimodal Transportation Inventory with AI and interagency collaboration. Ben Stabler is a principal at DK's Associates, a specialized transportation planning and engineering firm based here in Portland. He has over 23 years of industrial experience and leads DK's modeling and analytic practice. He's excited to collaborate with ODOT and several other Oregon transportation agencies on the statewide effort to build multimodal data for transportation system planning. Theresa Conley is a principal planner with the Oregon Department of Transportation, where she leads a team supporting implementation of Oregon's updated transportation planning rules. Theresa has over 20 years of experience in planning and community development, working in rural, urban, and international setting. Theresa has a Master of Community Planning from the University of Cincinnati. Here is some information about our upcoming seminars. And for those of you who are PSU students, STEP is a community of students passionate about shaping safer, smarter, and more connected transportation systems, and brings together students from across several disciplines for guest speakers, field trips, and other events. STEP is open to all current PSU students, and they're excited to meet more students interested in transportation. And as an overview of today's seminar, you expect the speakers to present for about 45 minutes, followed by a Q&A. For those of you online, we will be receiving questions through the Q&A feature on your Zoom control panel. If we run out of time for all your questions, we will give our speakers the opportunity to email written responses for any question left unanswered. We have enabled closed captioning, but you must click on the CC feature to view them. We'll be recording today's seminar, and it will be available on our website later today, along with the presentation slides. If you're tracking professional development development hours, the seminar is eligible for 1 hour of continuing education credit. For those of you in the room, please, we'll pass around the sign-in sheets so that you can get credit for attending today. With that, I will hand over to Ben and Theresa.
You, right, nice, you make sure technology, right? All right. Thank you all for being here. I'm Theresa Conley, a planner with the Oregon Department of Transportation, and I'm leading up a team that's supporting jurisdictions within our metropolitan areas to comply with updated transportation planning rules. And as part of that, ODOT heard loud and clear, we need some support on the new data that's required to do more robust analysis of our transportation systems and complete our transportation system. So this project was birthed to see if we can produce I'll call it statewide data set for our bigger metro areas to support local planning and hopefully other work too. So we'll talk a little bit about that. Of course, it's Ben, and you'll give the intro, I suppose, when you up. So let's see. So we had intros, and I'll provide some project background and then hand it over to Ben to talk about AI in action and kind of what we're learning. I think that'll be a pretty juicy part of the presentation. And then we'll talk more about collaborative management. This isn't just a technical and a data project, but we're working with 48 plus jurisdictions. It's very collaborative and political. And so that's a big piece of it too. And then we'll talk about key takeaways in both of those arenas and hopefully have a good amount of time for discussion. So this is a complicated project, as you can probably already tell. And so we have a lot of great minds in the room. On the ODOT side, we have staff from around the agency. I'm a planner. I'm not a data person. My GIS expertise expired about 20 years ago. So we have, folks from the GIS unit, from the modelers. We had people that work more in enterprise data management at the agency that are involved. So really big team on our side, and same with on the consultant side, as you can see on the screen. There's some of our project partners. So what can you expect to learn today? We'll share about this project, the multimodal inventory and key lessons. We admit it from the outset, it's a very ambitious project, and we know we'll find our limits in different areas, and we're starting to find some of those, and we'll share that today. We'll share a little bit about the updated transportation planning rules and what it means for jurisdictions and how this data can support adherence and alliance with those rules. And then dig into AI. We're all kind of learning as we go with it, right? So we'll share our takeaways here, how it's really a great resource for this project and how we can continue to improve upon what we're building here. We'll talk about interagency coordination and about how we aspire for this to be a living data set, right? Not a one-time, snapshot in time data set. So I already shared a little bit about the project background. In 2022, the transportation planning rules, which guide transportation planning around the state for cities, counties, ODOT, regional entities in some cases, they were updated in 2022 to integrate the climate-friendly and equitable communities rulemaking spearheaded by the Department of Land Conservation and Development, which owns the TPR, we'll say. And ODOT works really closely with DLCD in implementing TPR and supporting implementation. So that's where we came in with this project. These updates are really focused on metropolitan planning areas. So you'll see the stars on the map. These are the Oregon-based MPO areas. The rules apply to cities and counties within these MPOs, the metro and the state. And the updates to the rules were really focused on achieving as a state our climate and equity goals and targets, right? How can we work together to move more strongly in that direction? And a big piece of that is knowing what's on the ground in terms of our infrastructure. Where are the gaps and deficiencies? Where can we, how can we create better solutions? And so that's what this does. For those of you who aren't steeped in transportation system plans, I included a couple of slides just about, what is a TSP and what's the flow and how does this data fit into it? So generally, always start with a community conversation, right? That's good. The ground level for community planning. And then, what do we have on the ground here? Hear from the community, also look at the data. What are the existing conditions? What will things look like in the future? Run that travel demand model. And then from there, define solutions based on goals and objectives discussed earlier with the community and create that project list. And then of course, keep it as also a living document, revisit, track performance. And so I did a little back of the napkin about where this data fits into that process. And really, it could be every step. And that was pretty exciting to me. From the beginning, helping community members visualize what's happening, right? That the map that people put Post-its on, or, you know, whether it's web-based or in real life. The existing conditions, of course, that's the core purpose of this data, what's on the ground now. We find ourselves and some of our partners that we're working with already jumping forward to, but there's a sidewalk gap. We really need to fill that. This data is, you know, what's on the ground now, but it, you know, leads to the next conversation, analyzing future needs. The data is being set up to be used for this analysis where, you know, whether it's crash analysis or level of traffic stress, that's been something pretty important. And it can be used to, you know, through the rest of the process, defining solutions, creating that project list and visualizing it with the line work we're producing. And then we're also keeping an eye on performance tracking. So this is another thing required in the updated transportation planning goals, is some really specific performance measures that jurisdictions track against. And I included a couple up on the screen, including level of traffic stress. That's why it's been pretty important to our project team to have the data to run the numbers on. So what is the multimodal inventory project? It's ambitious. It's an ambitious and collaborative effort. You'll hear those words a lot, to produce this multimodal data set supporting local planning needs, and aligned with the updated TPR. And this last piece, something that can be maintained over the long term, is something we're really grappling with now, and is really important to the agency and to continue to support local jurisdictions. So project outcomes will be, fingers crossed, a standardized multimodal data set that complies with the rules, and that's both the geometry and the attributes, so the line work and then the data behind that about, you know, what's in that line, the condition, the width, etc. Methodologies, so this can be replicated and tracked and made and understood to be authoritative. And QA/QC, so making sure the data is accurate, doing those checks. And a long-term data management and maintenance framework are core outcomes for the project. These are the data sets that we're working on producing right now. And this is almost like pulled directly from the TPR, from the transportation planning rules. The data in bold, we're familiar with. We really largely have that already, whether it's at the state level or at the local level. So roadways, freight routes, freight terminals, also on the other relevant data side, we need to integrate crash data into this data set, and we have that. ODOT provides that, shares that already. So we're building on those existing data sets. When we're working at the scale, 48 cities, and I think in additional counties and councils of governments, metro, we had to think of creative and effective and efficient ways to produce that remaining data. So the consultant team said, what about AI, you know? And so that's the route that we've taken. And then we'll share more about data we're producing. So the data layers shown in italics are developed using AI, and then with manual inputs too, updating that data. And you can see where the asterisks are, where it's existing data that we've done some manual updates to. And I think that's assumed with the AI data that there's the team's getting in there and adjusting it. All right, so early on, we realized, okay, 48 jurisdictions, we can't just do a full sprint with all of them at the same time. And so we quickly realized this is going to have to be an iterative project for that reason. So we completed a multimodal inventory needs assessment across all the jurisdictions. What's on the ground now? Give us just a snapshot of your data. The team ran through it and proposed a cohort model. So when you're looking at steps 2, 3, 4, kind of even, it's iterative. We have 3 cohorts. We're starting with a pilot group of 5 jurisdictions, which has been so helpful to learn, get their honest feedback about what's working, where the sticky points with the data, and then we're integrating those learnings into the 2025 cohort and the 26 cohort. And for each of those, we're receiving an updated data set, doing a deeper dive analysis of what's missing, what we need to add to comply with the rules, processing, integrating the AI data, and inflating those local data sets. At the same time, we're integrating those learnings and kind of slow rolling the long-term management plan and building it as we start expanding those conversations too, now that we're in this second year of the project. And so the outcome will be data sets for each jurisdiction, and then a conflated statewide data set that hopefully we can use for state level analysis, regional, keep up to date. So AI in action, I'm sure you're curious to hear what we're actually seeing as we're processing the data.
Cool, thanks. All right, let's see here. This is my second Friday transportation seminar. I just looked it up. It was October of 2014. That was the last time that I did this 10 years ago. And that time I talked about estimating travel patterns for the Idaho statewide travel model for the long-range plan for the state of Idaho using cell phone data, which was interesting because so everyone's, we're doing so much of that now. So anyway, thanks for having me as well. Okay, so as Theresa was saying, we've got this big initiative to build data across the state or in the jurisdictions in the MPO areas. And there's a lot of data set that we already are familiar with, right? We already have roadway data, we have some bike data, we have, some sidewalk data, but especially in the active transportation space where there's a lot of planning going on, that we need more data and we need creative ways to generate it. So the basic idea is to start from the jurisdiction data that's available, the existing inventory data that the cities have, the counties have, public works departments, GIS departments, and so forth. And then use high resolution aerial photography to then use machine learning and AI algorithms to estimate or impute bike inventory data, sidewalks, widths, crossings, stripings, things like that, okay, as best we can to kind of jumpstart this data set statewide. And then, we have a significant consultant GIS team to help us clean up that data, review that data, get it into the standard system, and so forth and so on. All right, so what are we doing? We're focused mostly in ped and bike and intersection data. That's where the inventory is the weakest. And where it's also become a lot more important over the years to know the quality of the sidewalks, the condition for accessibility, different reasons, right? So those data sets are a little bit weak historically, and they need to get better as we do more planning in those areas. We did some stuff with transit as well. I have some more pictures and stuff, but transit priority treatments like bus only lanes and things like that. Sometimes that data is not available, but generally transit systems, they're a smaller footprint, and so they're easier, and their data is there and it's available, and there's active taking care of it because there's service plans and all this stuff for it. All right, same way with the roadways. It's really the active transportation stuff where it gets a little thin and it needs help. So some examples, this is generated from high-res aerial photos, and then using image detection and machine learning techniques to try to build out the line work. That's really the project. So this is our pilot. I have a bunch of screenshots. So this is our pilot data set up on ODOT's TransGIS. It's internal to the project, but eventually it'll be published for the public. And it's the CFEC data. And this is the example of the road data that we've built. So this is a combination of the local agency data plus our AI techniques. That's the roadway data. We have all of these. This works. Okay. So this is what's in the roadway data: the location, who owns it, maintenance, facility types, arterials, that kind of stuff. But stuff that is harder to do or newer stuff is the condition. We added traffic volumes using some big data providers if it's not available, because sometimes the agencies have traffic counts and traffic data attached to the data to the roads. Sometimes ODOT does it as well, and then if there's holes, then we try to fill that in with big data techniques. So AI, for example, is helping us with the imagery and then the algorithms on top of it to impute things like lanes, but it has a hard time because of the striping, right? That's one of the key things it's using to determine lanes. So if the striping is weak, then the algorithms aren't as good in there. computer vision or video detection algorithms. We've got bike route data. So again, here's an example in Albany of the data set, the prototype data set or the pilot that we're working on now. So some of the things that we want in this data for planning, like, so we're trying to build active transportation, right? Make the world better for walking and biking. So we want things like width and condition, right? Nobody wants to walk on, short little junky old sidewalks. They want nice big sidewalks. They're safer, they're easier for everybody, so forth and so on. So, that, like, you think about like the entire state and all the MPO areas and all the sidewalk, it's huge. Right? It's a huge data set. And so it's, so that's the kind of stuff we want. And that's what, it's helping us and it's doing a good job, but it's also struggling when there's trees. That makes sense, right? Tree coverage. So, it just can't see it. There's a tree in the way and you're taking a picture from up top. So you can try to impute it, right? If there's trees and you see it's 8 feet, or 8-ish feet and then trees and then 8, okay, I think it's 8, but those are the kinds of things, that we're having it do, and it's helping. Buffers are important, right? If there's curbs or bike bollards or things like that. So, this is the kind of stuff that the team is helping manually clean up and review. And so we have a consultant team that's helping clean it all up. And then meeting with the locals to then have the locals clean up the data. So for example, like City of Beaverton, GIS department to help review the data in their community. Pedestrian routes and sidewalks, again, the same kind of stuff. We're looking at the condition, stuff like that. The widths, we're trying to determine widths. We're doing a pretty good job at it, but sometimes it's struggling with the widths. We have classifications, and of course you have a lot of different data sets coming together, right? Because it's not like this is the first time in the state that people want to try to maintain in their GIS the width of the sidewalk. A lot of these jurisdictions already maintain it. Some of them just say sidewalk, present or not. Some say sidewalk to 1 foot. Some say in bins, so when you're working with 50 communities, you've got to have a lot of discussions about what do we want, how do we want to define a sidewalk width? How can we agree as a collective group on a definition? So there's a lot, as Theresa said, and I think you're going to pick up the second part of it, which is there's a lot of collaboration and discussion with the stakeholders to come up with an agreed upon standard or a schema, a data schema. Another one is crossings. Okay, so this is another thing that we're using. So, it's detecting the crossings based on the sidewalks, the stripings, or not the sidewalks, but the crosswalks. And again, it's generating an inventory for us. It's pretty useful where we're cleaning things up, tree coverage, paving sometimes, or pavers are causing some issues or not. The lengths of the crossings, it's kind of doing a pretty good job. Yeah, so, there's just kind of these details, typical, when you ask a computer to do something, you got to be very, very specific, right? It's sort of as if, if you use ChatGPT, right? The more specific you can be in your prompts, the better you're going to get an answer, right? You got to, because, it's not a human, it doesn't know how to really connect and guess. It sort of needs very specific instructions. So the more specific we can be, the better we can be. But if we're specific about a whole bunch of things, that just puts a lot of demand on the system for it to figure out. All right, so there's some review on that. I think it goes back to you now, Theresa. And then we have some takeaways at the end that I'll come back for.
And we can get way more into the weeds on what Ben just shared too. So just whatever data set you want to dig into. Okay, collaboration again, critical to the project. And this is stressed from the outset, not one of our learnings necessarily, except we're learning more about how it needs to be done. Right. The jurisdictions, the pilot jurisdictions, Albany, Salem, Kaiser, Beaverton, Ashland, we owe so much to them for helping us refine the data set and improve our processes and make fixes now. So when we do the other 40 jurisdictions, we're even more efficient. So we owe a lot of gratitude for helping those jurisdiction staff helping reveal our blind spots with the data. One thing that came up was, and Ben mentioned, the width of the ped crossings. Because we're using center lines of the sidewalks, the crossing line extended from center line to center line. So it grabbed a lot of the actual sidewalk. And so we had to do some post-processing in GIS to take, a land cover polygon and subtract out those bits of sidewalk. And it's kudos to the Beaverton staff for being like, that doesn't look right. Let's work on that. So definitely, we've had blind spots revealed that made the project stronger, the project data. And also ensure that the data is usable, right? If the city wants to use this crossing data to make accurate assessments about safety and crossing distance, we need that to be as accurate as we can within acceptable margins of error, we'll say, the limits of our capacity. Engagement is really critical to make sure the data sets, address local conditions. There are some things like sidewalk condition. AI can't identify obstructions in the sidewalk, we found, at least the vendors we're working with. We had to have some conversations with the working group about how are we going to define sidewalk condition when we know, sure, there's the objective, the width and the age of the sidewalk, but what about accessibility? What about user experience if there's an obstruction or if there's uplift? And those were things we had to talk with partners about and come to agreement that we're really going to focus on just some physical attributes, and then hopefully we can grow the data set to encompass more of the actual user experience accessibility. That partner engagement has really been key to work through some of these really tough conversations. And partner engagement keeps us focused on producing a durable data set. Maybe there are some attributes that we focus on more than others. And those are, inherently collaborative conversations. And right now we're really digging into what kind of platform works best to manage and store the data long-term. We have a committee meeting scheduled December 3rd, so I don't want to get ahead of them, but I'm hearing a lot, data arrives to us in a geospatial, GIS-based format. That's likely a format that would work for, storing it long-term. So we'll see what the committee says on that, but, through conversations, it's like this is more approachable and then maybe a data lake or some larger solution. We are really tracking through one-on-one conversations with committee meetings. Internally within ODOT, we've had some conversations. Of course, the project from upset defined goals. And Ben produced this Venn diagram here to see how we're doing with, we do a GIS-based solution. Is it meeting the goals that have been expressed by these different core partners? And we think we're on track. Collaboration critical, clear governance of the data is really important for that longevity and to ensure that we are working with authoritative data sets that jurisdictions can rely on. Of course, TPR compliance is number one from the outset. We want those transportation system plans that comply with the rules. And we're hearing a lot about support. We are producing some novel data sets and new data around, especially the active transportation system that jurisdictions didn't have before in some cases, like center lines of sidewalks and, pretty small communities that don't even have GIS departments. What's ODOT's role, the state's role? What is the Council of Government's role or Metro's role in helping to maintain those data sets? We've heard there's a need, but we have to flesh that out and see, learn more about that need and how we can step up from different points around the state. So a governance strategy is really critical, right? If all these jurisdictions are gonna partner together long-term and maintain an authoritative data set. So next steps in the projects are, working through intergovernmental agreements and defining roles, whether it be ODOT, councils of governments, staff. And some of these things we, have started from outset of the project, defining, classifying the data, identifying standards. These things are integrated throughout in our kind of iterative process where we double check, make sure we're still on track. Some things, the data storage and technologies, how and where will we store the data? That's moving into that conversation now, but all really critical. If you have questions about this slide, I'll point to Ben, but this is a example workflow. So if there is, if the data is stored centrally with the state and TransGIS or some platform, similar platform that we have capacity to manage, what would it look like? So jurisdiction A could maintain the bike facilities and roadways layers. They might do that currently. So they'll just keep them up to date. And on some regular cycle, send them over to ODOT for that statewide conflated data set. And maybe somebody in our GIS department will take those steps to build, to conflate or combine the data sets and then make that publicly available for researchers, for other folks. And so there'd be this ongoing partnership, uploading into the central database. So these are workflows that we're thinking about right now at project team level. See, here's a little bit of a status update where we're at, keeping ourselves accountable. So we do have, based on local conversations and internally with ODOT and our committees, tentative agreement for that hybrid solution of we need the state in a role and probably regional governments as key partners to manage the data set long term. We don't quite know what that will look like, but we've heard that. We're working on these, as I mentioned earlier, from the get-go of the project. We're tracking how the data is produced with source, whether it's using replica for the travel volumes or Ecopia, which is our AI vendor. We're tracking that as an attribute in the data. And so the collaboration is ongoing through the life of the project, and after that, technologies we're defining now, right? Whether it's a geospatial solution or something else. And yeah, we need to dig into kind of the collaborative part. All right, so key takeaways.
Back to me.
It's you.
Okay. Yeah, an interesting thing too is the data agreements are different depending on the data source and the agency or the vendor, right? So something to think about as we build this big collaborative data set is there's end user license agreements or restrictions on how we can use the AI generated data. And then all the agencies also have their own data, right? And so we're working on data sharing agreements or MOUs or IGAs across the agencies to support the creation of such a data set. All right, so it's definitely AI is helping us here. It's cost effective to get aerial photos of the across the area and run their or have them, our vendor, run their machine learning algorithms to impute or estimate the multimodal data inventory. So you know, it's useful. It's difficult sometimes in certain situations, like we talk about tree coverage, you know, crosswalk widths. You know, when you start to convert pictures into line work or geometries, nodes, points, and polygons inside of GIS, the crosswalk may go a little bit into the intersection, but the link, you know, the links all connect, and if that's kind of fatter, then maybe it bumps into the intersection polygon, and then, you know, these things are like, you have to all figure out when you do GIS. It's hard to do, you know, for 800,000 locations with an algorithm. You can get it 56% right, and then, you know, it's a lot more work to get the last little bit. So these are the kinds of things that we're working through in the project. So I think, you know, there's still a tremendous amount of expertise GIS skills being done in this project, plus all the work for the locals to review and the meetings and the outreach to clean it up, get it put in and get it published. So, you know, that's to be expected, but, you know, an important takeaway. You know, here, this is cool, right? In Labs edition here, so AI generated data.
The gaps.
And yeah, right, exactly. And then look, like in some spots, right, like little missing things. I don't know, you know, so like, I don't know, in here, and but you know, it's a good start. You know, it's the detail, right? This is the key, right? Is it can do a good job at helping us get some of the general stuff together. It can do pretty good. It's kind of Swiss cheesy a little bit in terms of there's gaps in different ways in different parts. That's to be expected, right? And we need to clean that up and learn, it'll get better and better. Our vendor is doing this in other places as well, and I'm sure, they're getting feedback from us and working on the system and making the data. You'll see this a lot. Look, if you see in the industry, this, using AI to update transportation asset management or inventory data is a hot topic. We talked about overpasses, we talked about trees, but overpasses, right? These things, they're tricky, right? And all this stuff, right? So needs help there, but it can learn. I think also, we talked about this a little bit, but we're working through building a data set for updated TPR rules, right? For climate friendly, equitable communities. And we need to there's still a lot of work to do to define exactly what that looks like. What is, a sidewalk condition? We had a lot of discussions recently about bike planning and bike boulevards and separated, not separated, shared, all this stuff, right? This is a big topic, of course, in Portland and in other places. Getting an agreement on a standard for that to have data today, but also into the future, right? And it can change, right? That's some of the work that we're doing in the governance and the long-term data management plan discussions is this data set won't be frozen. It will be alive, and we'll organize a group of folks to help take care of it and define updates, as the practice changes, the data needs to change too and keep up with it. Another key thing is, working together with the partners. So ODOT is, kind of jump starting this big data push for the updated planning rules, which is a super great contribution into the industry. And all the jurisdictions and counties and COGs and stuff are helping and moving forward. But it's a lot of work, and everybody has day jobs in addition to updating data sets for all the latest stuff, right? So I think we're more and more working on, building engagement and getting everybody involved to help take care of this thing, because it's getting started, but it's going to need to be taken care of too into the future. This is sort of maybe the same idea here again, but engagement is really key, right? And we've got a lot of different partners on this. We have small agencies that don't have GIS departments, just maybe a planner. We got big agencies that have a significant GIS department, who have strong opinions about how data is managed because they've done it for years, So building consensus enough so that we have a plan and we can all move forward together. It's planning. All right, so a couple key questions to end with. To seed the discussion, what are opportunities and challenges you see with using AI for transportation planning? What potential planning and engineering uses can you envision beyond transportation system plans, TSPs? This is a discussion we like. Modeling, accessibility analysis, all sorts of cool stuff. And what are innovative ways to engage and build a community to support this data long term? And that's us, but we'll stay here. Questions? Li Ming, you're up.
Did you come up with the questions? I do have a bit of kind of instructions for those who view online. So for those who view online in the webinar, feel free to submit your questions. Use the Q&A feature in the control panel on the bottom of your Zoom window. And then we'll probably start with the question in the room. Anyone? Or probably let you
Theresa, take it.
Your question.
Here,
I think I saw you first.
I'll let you lead the charge.
So there's a discussion about condition for the sidewalks and how like uplift and other scenarios is outside of the current scope. Like, was there any, what is the conversation around how you would approach that perhaps in the future to gather that data and maintain it? Or has that been a topic?
Yeah, well, we talked, what would it take? And this is where, the last slide, I think one of the bullet points was some things really take local knowledge. So it would have taken the project team, and I think I had a short conversation with the project, the consultant PM. Do we have the budget to go and roll, to walk every sidewalk, even if we use technologies? to truly assess uplift and those pieces. So I think it would take some additive technologies or local input as they conduct planning. And we're building a data set that local agencies can go in and add as data is updated. There's development and new sidewalk segments put in. We have an idea in the back of the room about
Well, I was
All
wondering,
this
have you
problem.
thought about using AI on Street View versus satellite and for that type of aspect?
early on in and this might be before Ben joined the project team, but there was conversation about being able to look at an angle. And I think it was still prohibitive for the vendor that we're using. Or it would have just absorbed so much of our budget. So, I mean,
And it is being used a lot in the cleanup. Yeah, in the manual review and cleanup.
yeah, so we are, yeah, definitely we're using desktop review to go in and fill those gaps in last edition and other places where there's the, tree cover blockage. But yeah, this will be something that we'll have to talk about through conversation about long-term management and once this down payment is in place of the ODOT funded effort, how can we come together and which data sets are we going to prioritize maybe to put extra funding towards improving? Oh, and then go ahead.
Okay, yeah, the underlying assumption here, of course, is that we're increasing speed and or quality of the data collection versus a manual process, just like you sort of just alluded to, that, the reason we don't have the data set right now is we haven't been able to afford it. When you develop, I know the AI vendor is another one that's not present in the room, but I wonder if y'all could speak to any standards for quality that you had for the vendor. In terms of like completeness, spatial accuracy, those
Do we
sorts of
want to
things.
take that one then?
I want to hear you say first, but yeah.
There's something, so DKS has the contract with the vendor, we have a contract with DKS to provide the data. And so there are ongoing conversations, and we had one at the project team level about acceptable margins of error. So we could really understand and hear from, Ben and team are having those more in-depth conversations with you. Yeah. I understand there were some in-depth conversations about the intersection point data, which you've just received. We haven't really dug into because I think there was a lot of, I can't speak for you, but pushback of, hey, vendor, we agreed to this, work on it a bit more. And I'm probably getting.
No, that's fine.
Talk to you.
Yeah, no, I mean, that's.
The vendor.
It's a difficult thing to say, to say like, 95% of the sidewalk width should be accurate. Because there's no way to prove that really. You can sample, and so there's been a lot of discussion about that. We do have some ground truthing. We do have review of a few percent of the data. It's different in different areas a lot, different jurisdictions, different data sets, different tree canopies and other things. So we've had to talk with them a lot about kind of just it's not good enough, keep cleaning it up, like we spot checked a bunch of stuff, like look at this. And the more we can be systematic in giving feedback, the more they can, or the more the issues that are uncovered are systematic, the more they can make improvements to then make big chunks of improvements rather than just fixing one thing at a time kind of. So we don't have like super specific, like quality control numbers. It's a little more fuzzy, planny, and a little less engineering, but it's kind of a constant theme in the discussions.
And finding the really priority things to clean up. So one of the screenshots earlier on, you could see a sidewalk segment was highlighted and it was half of the box around a whole block. And so, yeah, so one of the early issues that I think we identified as a project team was, wait a minute, that's the sidewalk segment that covers four streets. How is that going to effectively be used in planning? And so we prioritized conversations with the vendor. I believe DKS went back and said, this is a problem, we really got to clean this up. Can you help us re-segment for the two subsequent cohorts, right? Because we're doing those 3 groups. So from the pilot work, we saw this. And so we prioritized time and materials on this. So that way you can say, okay, I want to know the sidewalk width generally on Elm Street. So you could get Elm Street and not Oak Street and Maple Street too, and Apple Tree Street.
I think the vendor too is, they're in a new space also, they're learning like, oh, well, this comes out as uniquely whatever it was, 8 feet or something, well, it makes sense for us to cut it for this, but their algorithm's just spitting that out and, not this and, so it's kind of like.
The algorithm,
Kind of getting to know each other.
yeah, the algorithm was based on width initially, and that's why it grabbed, so this is all 8 feet.
Right.
And, that was the early learning. And then, so you and then the woman in red.
So I may be interpreting this incorrectly, but I'm curious with the cleanup of data with how there was that dedicated GS team and then it went to local context with the community jurisdictions hanging up. I'm curious with communities that have less resources or the smaller communities that don't have GS team dedicated. From an equity lens, how did y'all address that challenge to try to create data as accurately as possible?
With the, so with the small jurisdictions, my mind immediately goes to down south in the Rogue Valley area. There's a good number of small cities within the parts of the metropolitan planning organizations. They have a really strong partnership with the Council of Governments there and a strong JS staff. And so they've been in the room and you seeing the data. So that's where that regional partnership really comes in. On the other hand, some of those jurisdictions are the ones that are most excited because they don't have any of this data. One of them, I think, maybe they didn't have GIS for their roadway, So this is a huge boon to small cities. But as we were talking, I was thinking about, well, what about the upkeep? And there continued, so there's this great down payment for a small city. What does it look like to actually keep it up to date over time? And so that came to mind for me. So that could be. You want to add anything?
Yeah, I mean, in some cases, the councils of governments or the MPOs already serve kind of a coordinating effort, so that's helpful. But yeah, that's, I don't know, the main thing we're doing there, I guess.
And was there another layer to that question?
Yeah.
I was curious if there's any sort of focus on the side towards putting more resources towards communities that have less resources themselves.
Yeah, I mean, I would say indirectly, yes. So the contract requires QA, QC of, I think, up to 5% of the data that's written into the contract, and Ben alluded to it. And we've had conversations about where we need to prioritize at times. So it's not spread like peanut butter across every jurisdiction. It's where we see the really dramatic issues, for example, with tree cover. So in this case, let's focus on these really treed jurisdictions in the Willamette Valley and address that. So that's just one example. It's not really should we focus more time on communities with fewer resources? But I think we do, because there isn't the staff there. And so, between the two, we fill the gap. In the Portland area, I think the larger cities with strong GIS teams, they're able to maybe put more hours towards the review of the local data and provide input and corrections, or maybe even go in and do the line work. It's happening with a couple cities, whereas then we would do the line work for our city.
I think on that point, just to follow up is maybe talk about which 5 cities you're working on with now and for next year. I mean, are those spread to smaller jurisdictions that are in need of this type of data?
So we are working with probably 20 to 30 jurisdictions for the 25 cohort. We're actively working with.
Oh, I thought you said 5.
5 is so we have 5
Pilot.
pilots. So we're kind of like the 2024 into 2025.
Oh, okay.
I hope to deliver the first data set to the city of Albany and also the city of Millersburg next week. And then we're
Like Ashland, Beaverton,
They're the
Wilsonville, Albany, Millersburg,
yeah, Wilsonville's, I think, in the 25 cohort. So we're actively working with
some of the
them.
conversations.
I can share a link in a little bit of how the cohorts
Yeah,
break
we
down,
can
but
put
it's
the-
the whole gamut of size jurisdictions.
Yeah.
We also spread the Portland jurisdictions throughout because we knew we couldn't just save Portland Metro for last, we have to, you know, spread the resources, our resources around. Some of them more complicated, areas with complicated infrastructure. Okay, go ahead, question.
I had two small things. So first, to the very first question about sidewalk condition, I wondered if you looked at all at project sidewalk. Heard of that? I see some nods, but it's a crowdsourcing tool where they take you on street view. And it requires community buy-in and working with, I think it's the University of Washington and maybe. So just to see if you thought about that at all.
Unfortunately, I just checked, actually, it's a project by a UW professor. We actually have him over here for our track comment or the Pack Trends conference. He has a pretty cool project for crowdsourcing sidewalk condition, with particular focus on ADA compliance. But I just checked, actually, in Oregon, Newberg is the only city that has some data.
Yeah, I think I saw that too, because they only do it if you engage with them directly as like a partner and. Anyway, so potential future ideas.
That has numerous times in this particular project sidewalk. And we were hoping we would get to tackle this question today about just authoritative data, because it's come up from that set of OpenStreetMaps, you know, crowdsourced data, but really getting towards for this first data set, making sure we have an authoritative data set that local agencies know that can be authoritative for them to do planning. That being said, we are developing a collaborative governance structure, right? And defining how to maintain different data sets over the long term. So there's this obvious area of potential growth for the sidewalk condition attribute, right? And so that very well can be written into the, you know, the plan for future upkeep.
Yeah, and I was just gonna add, like, the local jurisdictions, you know, are the owners of the data, so they can manage the system, and then periodically it gets rolled up statewide. So like Newberg, for example, could be, you know, more integrated into that kind of effort. That can make its way through.
Yeah, local ownership is critical for this project, right, of the data. And yeah, there's, I don't know what the sidewalk condition is in Newberg, so it would, you know, or any jurisdiction, would be incumbent on them to update data when development goes in, sidewalks are replaced, when they get new accounts, etc. So if that is the local authoritative data set, there might be some post-processing to fit it in with the standards. A good fair core, I think we selected for sidewalk condition. So that would be a conversation.
So like a sort of a three-part type question. The first one kind of builds off of John and Greg's question. So currently only the aerial views. Is there any plan to use the street view or even leverage video data, particularly for intersections where that can be fairly accurate if those are problematic areas currently?
Not for the building out of the current data set.
Like in the future.
Sure.
Sure.
Yeah, I
We're
mean,
recording this, right? I mean,
Yeah.
we're in the mode of accepting, you know, ideas right now.
yeah,
So
definitely.
Another year-ish to build out a framework for long-term.
Okay, and then, yeah, the answer should be pretty quick to these. The second one kind of builds on that in terms of what's currently being done. It sounds like everything that the image models are detecting is going for manual review. Is that correct? Like the image model is not working by itself yet?
Maybe, I'm not sure how that's different.
So like if after a certain amount of training, we can be like fairly confident and just letting the model do its thing without needing, you know, to manually review. It sounds like that process is still.
Well, there's inside the vendor, they're doing some manual review and cleanup, and then they produce data sets that we get, then our team gives. And then and that gets cleaned up and ODOT reviews. And then if that's good, then that goes to the locals and then they do some review and then things feedback. So
are you hoping that at some point down the road that like some of those, I mean, that's like one of the main reasons like that we can use AI is to sort of eliminate, right, all of that manual check. Is the hope that maybe in the next cohort that some of that would be worked out and you could rely solely on what the image detection models are.
I mean, I would say that's probably the hope, but I think we're still a long ways away from that. Yeah, but I think it's gonna get better.
Yeah, I agree. I mean, I don't think for this project, next cohort will kick off in December, January.
Yeah.
But yeah, if the vendor's doing some manual work as well.
One last little quick one.
Sure.
You mentioned some levels of accuracy checks. Would you be willing to share like those rates at all right now?
I don't have them probably specific enough for you,
Okay, fair enough.
we can follow up.
Yeah.
I'll just share me being an anecdotal reviewer of some of the data. One of the things that we're struggling with, and I think we alluded to, is sidewalk width. The sidewalk width and condition are hard, especially when you're using an algorithm. So sidewalk width is fairly good for areas where it's easy to anticipate. You know, a residential area where the sidewalks were all put in around the same time. There's pretty simple infrastructure, but once you get into a commercial area where there's more complex pedestrian infrastructure, bulb outs, might be, you know, some bus, you know, pull outs, etc. That's where we see more. I saw more variability with the sidewalk data. So we're cluing in on a project team. So next time I'm reviewing data, I'm going to focus more on those complex. I'll skip the suburbs for the sidewalk review and look more at the urban core and see if we can clean that up a little bit more.
Yeah.
So that's just one point where we've seen pretty good in some areas and algorithm struggling in others.
Thank you. Okay, I have ask an online question for those that are basically not modelers and planners. How would this data impact maybe general folks? Why do they need to care about data inventory?
It'll strengthen local planning. I mean, that's the core foundation for the project, is so that when there's, you know, the local level community meetings or a committee getting together and, you know, looking at maps or just discussing where the gaps and deficiencies are, we'll have that data, and it's layered on top sidewalk data, different types of pedestrian crossings, whether it's closed, marked, unmarked. So the level of detail in the data will be much greater to allow for a stronger and more equitable planning. I mean, that's the core hope of the project and the feedback.
Okay, are there other states that are also doing this or similarly practice here?
Yeah, there are. There's work in British Columbia that they're doing similar type of work. In California, I remember hearing about Santa Barbara or somewhere where they're doing similar work with Caltrans and stuff. So I think it's happening in different places.
But at a statewide level, like where the dot is actually.
So some Midwestern states, is it Minnesota or Illinois?
Just a few efforts around.
In Rhode Island.
Rhode Island? You're working on it?
Yeah,
Oh, great, let's talk.
I'm gonna talk to you after. Although Rhode Island is like the size of Portland Metro, so I don't know if it's so comparable.
So for maybe up to this, I do know the project is ongoing. So a general assessment at this point in terms of the AI usage, AI application, do you think it's a win, or how much do you save in terms of time, in terms of cost?
Yeah, it's definitely helpful. I mean, because it can kind of build out a whole giant data set to start with, and you kind of clean it up. So I would say it's definitely helpful. I mean, if you think about if you need to build street sidewalk inventory where it doesn't exist, you have to draw it all.
But you
Right. So
of course, there are some cases you do have to, but there you can, the OpenStreetMap or maybe some other places you can start with.
yeah,
So you probably fill some of those gaps
right.
without AI, of course. With AI, you can eventually.
Yeah, yeah, I mean, that's helpful too, right? And that's a data source that also has issues and questions and different standards. So, you know, it doesn't come for free. Comes with work as well.
For the landing, what is the cause of those segment where they're missing, all right? They are not recognizing.
It's like Labs Edition.
Yeah, Labs Edition, sorry, yeah. So it only means some of the whole segments and some of the
This one?
street are not.
Yeah.
I don't remember why, that would be
There's tree
trees,
cover. I looked at the aerial and I. asked that.
the trees,
Yeah.
probably, yeah, I mean, there's a lot of trees in
So
there.
the cost for your team to go in and, well, I know it's taking, you saw the slide with the consultant team, right? There's a lot of folks on there, a lot of smart people.
Yeah,
It's a divide and conquer effort, I think.
yeah, there's a bunch of GIS folks in a bunch of different companies, plus all the local review too.
Yeah. I love
Yeah.
that.
But the point is it's the beginning. The point is everybody's building this data set and takes care of it moving forward, right? So there's also a lot of work to agree to a standard and then, care and feed for it for years to come.
Especially we officially close at 5. Maybe I'll ask one last question, at least, I'm curious, not sure, Ben or Theresa, you have this information. Do you know any of the kind of details in terms of the model used by the vendor, or those off-the-shelf AI models, or are those are something they train in-house? And then you can.
Ecopia is the vendor for the machine learning. Excel is the vendor for the aerial imagery.
Well, actually, you are not using, say, Google Maps or Google Earth or.
I mean, they have agreements for their data providers and for their technologies. Yeah, we're not directly doing it. They're doing it, so to speak.
Cool. Great, thanks. Thank you all for attending today's Friday Transportation Seminar. For those of you joining remotely, after the seminar ends, you will have the opportunity to complete a brief survey about today's event. It should only take a few minutes and we would appreciate your feedback. Thank you, Ben and Theresa, and thank you all for coming.